This is 1.6 piecewise graph. Piecewise function is pieces of multiple functions in one graph, basically. It is still a function, so you got to realize that. So as you put these pieces together, they create one big graph. The reason we're doing this after 1.5 is because 1.6, the piecewise functions, is basically multiple, two or more restricted functions onto one graph, which we'll see in the first example. So it says graph the following, show significant points, state the domain and range. Alright, so if we look at this, I just kind of follow the same steps as before. So we look at our restriction. If you notice, our restriction is the same number for both of these. Okay, so we got to kind of think about, it's not including either one, so that's something to keep in mind. There will be a hole at -2, but we need our boundary point for both. So I'm actually going to go and draw my boundary line on my axis first. It's at -2. Okay, since I'm going to have multiple boundary points now. So first, I'm going to deal with this. This is a quadratic, so you better be making a U shape type of thing. My vertex is, or my shift is left 3, so my vertex is -3, 0, right? Go from 0, 0, left 3. And then my boundary point, I plug in -2. Okay, so that would be 1 squared, which is 1. So my first boundary point is -2, 1. Okay, and it's a hole, -2, 1. Okay, now I'm going to deal with the other one. So this is a V-shaped, it's a absolute value. It's down 1, so my vertex will be 0, -1. And we need to plug into this one. So absolute value of -2 minus 1. So absolute value makes it positive. 2 minus 1 is 1. So it actually happens to be the same point, and it's still a hole, not included either time. Okay, so both of my graphs are going to go to that point. So that is actually an important point because it's going to work for both graphs. Now I'm going to do the quadratic first. Notice this is less than. That is to the left of my boundary, so everything has to be on the left side. I'm not going to continue it onto the right. So -3, 0. And luckily that is there. It's a positive 1 a value, so over 1 up 1. I could go over 1 up 3. That works, but notice I cannot do that on the other side. That's past my boundary. So when I graph it, I'm actually going to graph this way, which is a little different than when I normally graph quadratics, because I want to make sure I'm not passing that point. But it does continue to the left forever, so I do have an arrow on the left side. Now my absolute value is greater than, so all of this is what's going on the right side. That's why we can't have it cross, because otherwise it would not create a function. So I'm going to keep the same color because it's one graph, so I'm not going to change it. This is a down 1 shift, so from 0, 0, down 1. It's a positive 1 slope, so I can continue that. Notice I can keep going to the right, but I have to stop on the left. So I'll create my V. And there you go. There's my piecewise function. And it is one function. So it has a left arrow, a right arrow with a hole in the middle. So that's important when we're writing our domain. I'm going left forever. So -infinity, because it's the negative side. And I'm moving, and I have a hole at -2. So when we write a hole, we go up to -2, not including it. Then just past -2, not including it. And then how far right do I go from there? 0, positive. Now my range, how far down do I go? So my lowest point on this whole graph is -1 included, because it is a solid dot right there. How far up? I do have a hole, but notice it's actually included multiple times elsewhere, so I can keep going. It's an arrow up, so it goes up to infinity. Could actually also have done that on the other side. And there we go. That's our piecewise function. So we can do that with any kind of function. Now we have exponential. So our exponential, notice, kind of goes up like this. Our boundary is at -1, so I am going to draw in my little boundary line. Just to remind myself, I'm going to have something different on the left than I am on the right. The right side this time, it's included, and it's the exponential. The left side is a v. I'm going to draw it down because it is a negative v. Okay. So let's deal with this first. So this is an up one, oh sorry, a left one shift. Just going to do that. That's easier. And I need to plug in this point. So y equals 3 to the negative 1 plus 1, which is 3 to the 0 power. You need to know that any number to the 0 power is just 1. So I get negative 1, 1. Negative 1, solid dot. It's included. Okay, so now let's graph the rest of this real quick. So I'm going to go left 1. Notice we shift from 0, 1. The left 1 is the point. That is my key point. Then I need another point or 2. So I'll go. So from my key point, I'm going to plug in 0 and 1. So plug in 0, I get 3 to the first, which is just 3. If I plug in 1, I get 3 squared, which is 9. So that's going to be off my graph. But 0, 3. Remember, when you're graphing points, go from the origin, right? 0, 3. All right, think about how this graph would normally look. It kind of looks like this, right? Where it flattens on the left and peaks to the right. I don't draw anything to the left, so all I'm drawing, if I kind of think about it, is my peak to the right. Okay. Now let's do the other side. I am still going to use the same color, but change colors just for this. So this is a left 2, up 3, shift, plug in. Okay, so I get negative 2, absolute value of 1 plus 3. Absolute value of 1 is just 1, so it's negative 2 plus 3, which happens to be 1. So I end up with the same point. Again, it won't always work out that way. But a lot of people say, whoa, isn't that supposed to be a hole? Okay, since it's filled in for one thing and it's the same spot, we just leave it filled in. Okay, if it was a hole and now it says we should fill it in, we would fill it in. Okay, so kind of filled in dot, closed dot trumps the open dot, or overrides the open dot. Okay, so now let's shift. 1, 2, 1, 2, 3. My vertex, it's on the left side. Remember, everything in the graph has to be on the left side of this boundary because it's less than. That happens to be, so that's good. Now I can follow my slope. Can't continue this way because that's the end. I could do a couple this way though, because it does continue forever that way. And there we have it. That's my function. So my domain, I'm going left forever, right forever. My range, I'm going down forever and up forever. And notice it's continuous. There's no holes or anything like that. So it's negative infinity to infinity for both. Okay. Next one, we have a quadratic again for the top. And we have, it's y equals 4, so that's going to be a horizontal line for the second part. And we have multiple boundaries. So we have one at negative 3, and we have one at positive 1. Okay. Pay attention to what's what. So this horizontal line is going to be between negative 3 and positive 1. The u is only going to be to the right of the 1. Okay. So I'm actually going to deal with this horizontal line first because it's really easy. If I plug in negative 3, I get out 4. If I plug in 1, I get out 4. Doesn't matter what I plug in, I'm always going to have a y value of 4. Okay, so I'm going to plot those first. So I have a closed dot at negative 3, 4, and an open dot at 1, 4. And it's just a solid line in between. Okay. Now I'm going to deal with this. So this is a right 3 shift. And we got to plug in our point. Y equals 1 minus 3 squared, which is negative 2 squared. Remember, negative times a negative makes a positive 4. So 1, 4 happens to be the same again. Okay, so that point, it's still an open dot based on this. That is also going to be in my u, though. So I shift right 3, 1, 2, 3, yay, it's on the right side of my boundary. It's greater than, that's good. Then I can follow my pattern, left 1, up 1, right 1, up 1. Then I go from that new point, left 1, up 3, that's where we'd stop. This side, right 1, up 3. I could actually keep going, right 1, up 5, and keep going, because it is going to go on forever here. Okay. Notice I do not have an arrow on the left side. I have a boundary. It stops right there. Cannot continue past that boundary, so there's no function that is less than -3. It's only between those two and to the right of +1. Okay? So we have our domain and range. So my domain, leftmost point is -3 included. Then I get to a hole at 1. Notice how we deal with holes in the domain and range, right? 1, parenthesis u, parenthesis 1. And then we keep going. How far right does it go from here? It goes on forever. That's my domain. My range, how far down? Goes down to 0, including it, so a solid dot. And then how far up? Yes, I know there's a hole here, but notice it's filled in multiple places, so it goes up to infinity. Okay. So the last one like that, we have 3 pieces now. Okay, that's fine. So we have a horizontal line, just a number. Then we have a diagonal line. And finally, we have a positive u. Okay, so I'm going to look at my 3 restrictions here. Notice we have 3 now. -3, 1, and 2. -3, +1, and +2. Okay, so those are going to be my boundaries. My horizontal line is less than, so that's going to be to the left. Okay, remember, no matter what I plug in, I'm going to get out that number. So -3, 5 is my key point, and there's a hole there. Hole there. Okay, and it's a horizontal line. So I'm just going to have a horizontal line going out. Don't have to do any more work. I just know it's a horizontal line, and it's only to the left of that boundary. In between the 2 boundaries, I have this line. So I actually need to plug in. So y equals 2 times -3 plus 1. So that would be y equals -6 plus 1, which is -5. So -3, -5 is 1 point. Then I also have to plug in the other point. Y equals 2 times 1 plus 1. Y equals 2 plus 1, which is 3. So 1, 3 is my other point. Okay, so it's a solid dot for both of those. So -3, 1, 2, -5, and then 1, 3. Okay, and we can follow the normal shifts. So this is an up 1 shift, and we should follow a 2 slope, +2 slope. So if we kind of added all the points, you could see it does line up perfectly better if we did it right. Let's make a diagonal line right there. And it's no arrows. I am stuck on both sides, right? I have a boundary on both sides. And that's also true for my last one, which is this. There's no shift, which is nice. I do need to plug in. So I have 1, 1. And I have 2, 4. Okay. These are both holes now. So 1, 1 is a hole. And 2, 4 is a hole. Okay. And this is where a lot of people get stuck because they say, well, the vertex, I have to be between 1 and 2. My vertex is at 0. Okay, that just means we can't add that point. 0 is not on this graph. 0, 0 does not work for this. But we can think about it, right? If I had this vertex, we know kind of what this graph is going to look like. So I'm just going to sketch in only the part, it's kind of a curve right there, that we have included in the graph. And that's it. Okay, so my domain, how far left? -infinity. How far right? Okay, be careful, there is a hole, but it's filled in here, so we keep going. Hole, but it's filled in here, so we keep going. And then I have a hole at the very end of this this part, and there's no arrow, so 2, not including. Okay, my range, how far down? Right here, 1, 2, 3, 4, 5. That's the furthest down I go. How far up? So how far up do I go? Okay, there is a problem here. It's kind of weird. So I have, goes up to 4, not including, and then I just have a line at 5. Okay, there will not be a problem like this. Oops. There will not be a problem like this on the homework or the test, but that's how you would actually answer that. So I have this section going from here up to here. I do have a hole, but remember it's filled in somewhere else, so we're good. So that positive 4 is where I stop. And then I also have a jump to 5. It's confusing. Just don't worry about that too much. Okay. Number 5, for the interval 0 to 6. So notice these intervals are domain intervals. So they're giving us x values. From the x value of 0 to the x value of 6, what kind of a shape is that? So that's from here to here. So what kind of a shape is this? That's quadratic. Probably shouldn't have written that there. Sorry if you wrote that in, but this is a domain interval, x. Okay? This is also a domain interval. So for the interval from negative infinity to 0, so that's all the way over here to here, what kind of a function is that? Looks linear to me. Straight line. Okay, that's it. For number 6, it says write the function for the graphs on the intervals here. So we have 2 intervals to deal with. I'm actually going to tell you to cross one of them out. Let's cross out, we'll do the more difficult one. So cross out 2 to infinity. That's a linear absolute value. So you would just write the domain restricted function for that. So instead, we're only going to be doing from negative infinity to 0. That's the quadratic here. So we have our vertex, we have our extra point. So I'm going to label those. Negative 2, negative 3, that's my vertex. 0, 1, that's my extra point. Okay, so we're going to fill that out. So from negative infinity to 0, including it, we have a U-shaped with a vertex of negative 2, negative 3. U-shaped, remember, is y equals ax minus h squared plus k. That's something you want to have memorized. Okay, so I'm going to plug in. So I get y equals a to left 2 down 3, x plus 2 squared minus 3. Plug in my extra point now, so 1 equals a, 0 plus 2 squared minus 3. So 1 equals a, 0 plus 2 is 2, squared is 4. So 1 equals 4a minus 3. So I'm going to add 3 to both sides. 4 equals 4a. Divide by 4. And I get 1 equals a. Okay? So I can write my equation. Y equals 1 x plus 2 squared minus 3 if x is less than or equal to 0. That would be my answer. Okay, so that would be just the quadratic part. We could have a line, then we could have a v for those other two. So 7, the last thing we're going to do is practice plugging in points. Okay, the reason this is trouble for some people is they don't know which one to plug in. You follow the restriction. If the value, the x, that number, and all of these things, if it's less than 3, you plug into the first one. If it is greater than or equal to 3, you plug into the second one. So 0, that's less than 3, so I plug in here. So that's 2, 0 squared plus 1. 0 squared is 0. 2 times 0 plus 1, so I get 0 plus 1, so 1. That's my answer for the first part, A. B, That's a 5. That's greater than 3, so I plug into the second one. Pretty simple. You only plug in once. If you're plugging in more than once, you did something wrong. So I get negative 22. 2, that's less than 3, so I plug into the first one. So I get 2 times 4 plus 1, that's 8 plus 1, which is 9. 3, that's equal to 3, so I plug into the second one. So I get negative 12 minus 2, which is negative 14. And last one, negative 2, that's definitely less than 3. Okay, don't forget negative times a negative makes a positive. So I get 8 plus 1, which is 9 again. Make sure you write out your 3